These are solutions to Calc 3 final exam for the 5 p.m. class. Number 1, cosine of theta is a dot b over norm A, norm b. Dot product is -4 plus 20 plus 6. Numerator is going to be 22. Over the norm of A is 1 square root of 1 plus 16 plus 4. Square root of 16 plus 25 plus 9. That's 22 over radical 21 times radical 50. Theta is inverse cosine of 22 over radical 110/50, 47 degrees. Number 2, PQ is 121, PR is 4310. Cross product IJK 121, 4310, which is 20 minus 3, the opposite of 10 minus 4, and 3 minus 8, 17, -6, -5. So the area of the triangle is half the area of the parallelogram, 1/2 square root of 17 squared plus -6 squared plus -5 squared, half of the square root of 350. Number 3, -2, -1, 3 to 4, -2, 4. The direction vector is 6, -1, 1. So x is -2 plus 6t, y is -1 minus t, z is 3 plus t. Solve for t. X plus 2 over 6 equals y plus 1 over -1 equals z minus 3 over 1. Number 4, r prime is 3, 4 cosine t, -2 sine t. Plug in pi over 3. 3, 4 times 1/2 is 2. -2 times radical 3 over 2. So that's negative radical 3. The normal vector would be 3, 2, negative radical 3 divided by 9 plus 4 plus 3. That's 16. So 3/4, 2/4, 1/2, negative radical 3 over 4. Number 5, dx dt squared is 2. dy dt squared is e to the 2t. dz dt squared is e to the -2t, which happens to be e to the t plus e to the -t quantity squared, whose square root is e to the t minus e to the -t plus e to the -t. So when I integrate, this becomes e to the t minus e to the -t. Plug in 1, you have e minus e to the -1. Plug in 0, you have 1 minus 1, which is 0. Final answer, e minus e to the -1. Number 6, r prime is t squared 2t2 divided by its magnitude, t to the 4th plus 4t squared plus 4 underneath the square root. That's exactly t squared plus 2 squared, so the square root is this. So the unit tangent vector is t squared 2t2 over t squared plus 2. Okay, x is t squared over t squared plus 2. If I write it as plus 2 minus 2, this right here is 1 minus 2 times t squared plus 2 to the -1. I notice that the derivative of this will be the opposite of the derivative of z, since z can be written as 2 t squared plus 2 to the -1. Derivative of 1 is 0. So dx dt is 2 t squared plus 2 to the -2 times 2t, 4t over t squared plus 2. Therefore, automatically, dz dt is its opposite. We said -4t over t squared plus 2. dy dt, the y component, is 2t over t squared plus 2. Do the quotient rule. Bottom times derivative of the top minus top times derivative of the bottom, all over the square of the denominator. That comes out to be 2t squared plus 4 minus 4t squared in the numerator. So 4 minus 2t squared over t squared plus 2 squared. Okay, so t prime is this. To find a unit normal vector, remember, you can take any scalar multiple of that. So in particular, just lose the t squared plus 2 squared. I will also divide out a 2 to make it easier. So I'll have 2t, 2 minus t squared, 2t divided by its magnitude, which is the square root of 4t squared. That's also 4t squared. This is 2 minus t squared squared. So if I square this, I have t to the 4th minus 4t squared plus 4 plus 8t squared. That's going to change the minus to a plus, t to the 4th plus 4t squared plus 4, which happens to be t squared plus 2 quantity squared. The square root of that is just t squared plus 2. So that's the final answer for the unit normal vector. Number 7, fx is 6x squared y squared minus 15x squared y to the 4th. Fy, 4x cubed y minus 20x cubed y cubed. Fxx, 12xy squared minus 30xy to the 4th. Fyy, 4x cubed minus 60x cubed y squared. Fxy, or fyx, 12x squared y minus 60x squared y cubed. Number 8, z sub x is -2x. Z sub y is 2y. At the point -5, 4, -9, z sub x is 10. Z sub y is 8. So z minus a minus 9 equals fx, 10, times x minus a minus 5, plus fy, y minus a 4. Okay, you could have left it like that, but if you clean it up, this is 10x plus 50 plus 8y minus 32. Do a little bit of cleanup. 10x plus 8y minus z is equal to -9. Number 9, the direction vector is 4, -3. So the unit normal is 4/5, -3/5. This has a magnitude of 5, 3, 4, 5, right? 16 plus 9 is 25, whose square root is 5. So this is the unit direction vector. Here's the original fx. Square root of y is y to the half. So fx is 2 radical y. Fy is half times 2 is 1, x, y to negative half, x over radical y. Plug in 2, 4. This is 2 times 2, which is 4. This is 2 divided by radical 4, that's 1. So the derivative of f in the direction of u is del f dot u. Okay, so that's going to be 4, 1. Del f at 2, 4 is 4, 1. Dot 4/5, -3/5. 16 over 5 minus 3 over 5, 13 over 5. Number 10, here's the picture. You're going from 0 to 1. Y equals radical 1 minus x squared. That's part of a unit circle. So r is going to go from 0 to 1, theta from 0 to pi over 2. Of e to the x squared plus y squared is r squared. R dr d theta multiplied by 2 inside, half outside. So I have 1/2 times pi over 2. Take out theta. This thing does not depend on theta. So theta comes out, pi over 2. And e to the r squared times 2r. Integral is just going to be e to the r squared from 0 to 1. Plug in 1, you get e. Plug in 0, you get 1. Final answer, pi over 4, e minus 1. Number 11, this thing is r squared. So the square root of that is r. X squared plus y squared equals 81. R is between 0 and 9. So triple integral, z is going from -4 to 1. R is going from 0 to 9. Theta is going from 0 to 2 pi of r times r dz dr d theta. That's going to be r squared. This does not depend on z or theta. Take out the length of their intervals, which is 5 for z, 2 pi for theta, and integrate r squared dr. So that's 10 pi r cubed over 3 from 0 to 9. Plug in 0, you get 0. Plug in 9, you have 9 times 9 times 9 divided by 3, 81 times 3, 243 times 10 pi, 2430 pi. Number 12, x squared plus y squared plus z squared equals 9. Rho is going from 0 to 3. This is rho squared. So I'm integrating rho squared times rho squared sine phi, d rho, d theta, d phi. Phi is going from 0 to 3, theta from 0 to 2 pi. You might recall theta, phi only goes from 0 to pi. This expression does not depend on theta. Take out the theta length, which is 2 pi. So I've rho to the 4th sine phi, d rho, don't need d theta, d phi. So rho to the 5th over 5, sine phi, 2 pi's in front. Rho goes from 0 to 3. Plug in 0, you get 0. Plug in 3, you have 243 over 5. Take it outside with a 2 pi. Integrating sine of phi, d phi. This is 486 pi over 5. Negative cosine phi from 0 to pi. So negative 486 over 5. Negative 1 minus 1. 972 pi over 5. 13, r is t squared t cubed, f is x squared y cubed, y radical x, which is t squared squared, that's x squared, t cubed cubed, that's y cubed, and then here is y, radical x is t. So t to the 4th times t to the 9th, t to the 4th, or t to the 13th, t to the 4th. R prime is 2t, 3t squared. So f dot dr, t to the 13th, t to the 4th dot 2t, 3t squared, 2t to the 14th plus 3t to the 6th. That's why to integrate from 0 to 1, 2t to the 15th over 15 plus 3t to the 7th over 7. Plug in 0, you get 0. Plug in 1, 2 15ths plus 3 7ths, 59 over 105. 14, the partial of q with respect to x and the partial of p with respect to y are both 5. Therefore, f is conservative. So fx would have to be 2x plus 5y. Integrate with respect to x, f of xy is x squared plus 5xy plus a function of y. Differentiate with respect to y, that's nothing. 5x plus g prime of y, set it equal to 5x plus 4y. That means g prime has to be 4y, which makes g 2y squared plus k. So f of xy is x squared plus 5xy plus 2y squared plus k. You're allowed to write any function, so normally you can let k be 0 if you wish. Finally, 15, here's p, q, and r. Partial of p with respect to x is 0. Partial of r with respect to z is 0. Partial of q with respect to y is 18x squared y z squared. So that's why to integrate. So triple integral of the divergence of f dv, integral from -1 to 1 for x, y, and z of 18 x squared z squared dx dy dz. This expression does not depend on y, so take out the y. Length of that interval is 2, so 18 times 2. -1 to 1 for x and z, x squared z squared. So integrate with respect to x cubed over 3, z squared, x is going from -1 to 1, 36 divided by 3 is 12, 1 minus a minus 1 is 2, that's 24. Integral from -1 to 1 of z squared, 24z cubed over 3 from -1 to 1, that's 8, 1 minus a minus 1, final answer is 16. All right, so that was the solutions to Calc 3 final exam, 5 p.m. We are done with the course. So I hope you enjoyed the course. Everybody have a great holiday season and a happy new year. Okay, bye everyone.